Today, since I finished introduction of chapter 5 last time we met, I'm going to get started on the review. And we may finish today and we may not. We don't have to rush. We have another review day available on next Tuesday, followed by a week from today is exam number 2. And I'm going to use the review document that was distributed in class or is available on Brightspace. And I've highlighted some of the questions that I want to be sure and cover. But as is my custom, I want to answer any questions that students have first. If you have any specific problems, we'll deal with those first before I get started with this. All right. Well, since there are no questions, begin with chapter 4. I believe this particular document is numbered consecutively, so when we get to chapter 5, it doesn't restart. We just keep numbering. These first few questions are really simple, and they tell you whether or not you have memorized the symbols that I gave you in one of the handouts. The symbol for the element iodine. Right. Iodine is one of those elements that is represented by a symbol that can be derived from the English name. And it only takes one letter. Right. That's probably because iodine was an element that was identified earlier than any of the others. So it got first dibs on single letter. Like oxygen gets an O, nitrogen gets an N, hydrogen gets an H, because they were discovered earlier. They get dibs on single letters. If we have to go past, if we need another element that starts with an I, then we have to add the second letter, which is small. Remember, first letter is capitalized, second letter is small. The second one, lead, is one of those whose symbol is derived from the Latin. The Latin for lead is plumbum. So its symbol is Pb. Okay, and in Latin, plumbum means heavy. The third question requires that you remember, certain group names in the periodic table. When we talk about alkali metals, you just automatically think first column to the left. Those are alkali metals. So now all you have to do is just go down that list and see which one of these elements matches that one. And there's only one in this list, fortunately, that is an alkali metal, and that's sodium. And sodium is the symbol that's derived from Latin for sodium, which is natrum. That's why it's Na. Okay. Number 4. An atom with 45 protons has a mass number of 100. It must contain how many neutrons? So it doesn't matter what the symbol is. We're only interested in the details of 45 protons and a mass number of 100. So the number of neutrons is simply 100 minus 45, which is equal to 55. You have 55 neutrons in this particular isotope. Number 5 requires that you remember what you studied about the abundance of elements. The most abundant element in the human body. And that question is a little misleading, because when we say abundant, do we mean the one that represents the most mass, or the one that represents the most number of atoms? And it probably means both in this case. First of all, if it's going to be an element, you can go down that list and say, all right, which ones of these are elements? Hydrogen, oxygen, calcium, carbon. Those are all elements. Water is not an element, it's a compound. So you go to B, C, D, or E. Well, calcium is a minor component. Hydrogen, oxygen might be good candidates. Carbon is a part of many of the molecules in our body, because we are carbon-based life forms. But we're looking at the human body, which is mostly water. Very large portion is water. So that means hydrogen and oxygen. Now, if we go by numbers, water being the most abundant compound in our body, if we go by numbers of atoms, then we would probably say hydrogen. So that tells me that when this question asks for the most abundant element, it's asking for the mass, because hydrogen has most hydrogens have a mass number 1, and oxygen has a mass number predominantly of 16. So that's a ratio of actually 2, 16 to 2, or 8 to 1. That's why the answer that's picked here is oxygen, I think, because the author of the question wanted mass. The most abundant element in the human body is oxygen by mass. All right. Let's make some room. While we're here, let's go ahead and do number 6. CO is the symbol for what? Well, we know that carbon is just C. We know that there are other elements that start with a C. And if you look at the available answers, carbon monoxide is a compound. Carboxide is nothing. It's just a made-up name. Chlorine, carbon, and cobalt all start with C. Carbon is C, chlorine is Cl, and cobalt is CO. Number 7 is another element that starts with C. Only this element, copper, name is symbol is based upon the Latin, which is cuprum. So copper won't be CO. That's cobalt. Copper is Cu for cuprum. While we're here, Cr is chromium. Let me see. Since we've got plenty of time, let's do number 8 also. This is a detective story. An element's most stable ion forms an ionic compound with chlorine having the formula XCl. And since we're talking about ions, X has to be a metal. Okay. If the ion of element X has a mass of 89 and 36 electrons, and so it has 36 electrons and a mass of 89, a mass number of 89, What's the identity of the element and how many neutrons does it have? Well, in order to answer the last question, we have to know how many protons. So we have to identify the element first. We know that chlorine has a 1- charge, so that's -2. This one has to be a +2. And a +2 is obtained by how? It has 36 electrons. If it were neutral, it would have equal number of electrons to the protons. But since it's deficient by 2 electrons, that's how you get 2 pluses. You have 2 electrons missing. 2 negatives are missing. So that means the protons have to be 38. Okay. Now we can both identify the element and the number of neutrons. Well, the number of neutrons will be 89 minus 38. 51 neutrons. And 38 atomic number says SR. So X is SR. Okay. Now, the other possibility that you can use to identify an element, if you know what its mass number is, or you know what its atomic mass is, and those are 2 different values, then you can also look that number up in the periodic table, because the periodic table goes not just atomic number, but atomic mass goes from upper left and down, left to right, top to bottom, increasing. So if we say 89 and we look along and we look, say, okay, where's 89, 89, 89? Well, okay. Now, if we did that, we would have a tie between strontium and yttrium. So we'd need something to break the tie, and that would be a problem. So the method we used, identifying the atomic number, was the best approach. Okay. Let's go down to number 10. Clean this a little better. Okay, number 10. An atom that has 54 protons, 54 electrons. If it has the same number of protons and the same number of electrons, it's neutral. That's why I put that 0 there. And 78 neutrons. Well, if it has 78 neutrons, we could calculate the mass number. But you don't need it to answer the question. The question is what is the atom? What element is it? 54 protons tells you that it is xenon. Okay. So there's information there that you don't need. All right, number 12. How many neutrons are there in one atom of what is Sc? That's scandium. And it's 2145. All right. We know the number of neutrons is the mass number minus the number of protons. So really all we have to do is this. It has 24 neutrons. That was pretty simple, actually. Number 13, which one is a noble gas? Well, you know which column is all noble gases, the farthest one to the right. You just look and match it, right? Which one of these is a noble gas, right? We know that nitrogen, hydrogen, oxygen are all diatomics, right? And they're not noble gases. Carbon dioxide is not an element, right? It's a compound. So by process of elimination and verification on the periodic table, you know that argon is your noble gas. 14. The chemical formula Al2O3 indicates what? Al2O3. In this case, you have to look at the answers to see what the question is asking for. A says 3 atoms of aluminum and 2 atoms of oxygen. Well, that's obviously wrong, right? It's 3 atoms of oxygen and 2 atoms of aluminum. Not 6 atoms of each element. Right? Just go down by elimination. 2 atoms of aluminum, 3 atoms of oxygen. C is a good choice. And since we have E says none of these is correct, if we find a correct one, then E can't be right either. So we found our answer. It's C. That's just to check to see if you know what the formula of a compound means. 15, Si is the symbol for, right? This just checks to see if you've memorized those elements. Si is silicon. Okay. Who's next? 17. How many of the following did Dalton not discuss in his atomic theory? Okay, we've got a list. Isotopes, ions, protons, electrons, neutrons. So, how many of the following did Dalton not discuss? Well, you think back to his atomic theory, right? He reintroduced the idea of the atom and that every element is composed of these particles, atoms, but each element has different types of atoms. Okay, and that when a chemical reaction occurs, the atoms are not created or destroyed, they're just swap partners. They rearrange. Right? Now, in that discussion, did Dalton say anything about isotopes? No. Did he say anything about ions? No. Protons? No. Electrons? No. Neutrons? No. All 5 of them are absent from Dalton's atomic theory. In fact, his atomic theory arrived ahead of all of these other concepts. So B would be the answer. All 5 of them were absent from Dalton's theory. How about 20? The number of neutrons in Be. What is Be? You have to know what it is and where to find it in the periodic table. That is beryllium. Beryllium has an atomic number of 4. Okay. Now, how do we find the number of neutrons? We have to subtract this from the mass number. But we're not given the mass number. So we look at beryllium and it has 9.01. 9.01 equals the atomic mass. Okay. Remember how we arrive at the atomic mass. It's a weighted average of all the isotopes of beryllium. What is probably the most common isotope of beryllium? If the value is very close to 9, then probably most of the beryllium isotopes are a mass number of 9. And there may be minor, very small amounts of maybe 10 or something in that neighborhood. So if we assume that it's 9, then the number of neutrons equals 5. That's how we deduce the number of neutrons for this question. Which of the following is a nonmetal? In this case, you have to know where that zigzag line occurs in the periodic table. It separates the nonmetals on the right from the metals on the left. And you look to say, which of the following is a metal, which is a nonmetal? We look at all of them, and we see that cerium, cesium, calcium, copper, those are all metals. Carbon is the only nonmetal in that list. That was 21. Is carbon. '23 coming up. The symbol for the element mercury. This is one of those that you just have to memorize. Now, Hg is the symbol, and it's derived from the Latin. Let's see. I know H stands for hydro. Hydro. And then G stands for it means create. Hydrogenium, I think. So there are your two letters, Hg. What that means is hydro is water creating. Apparently, mercury was used, especially during medieval times, as a reaction with mercury would produce water as a product. That's the only thing that makes sense. But it's held over into modern chemistry, so we're kind of stuck with it. 24. Okay, the symbol N stands for the element. We mentioned this one earlier. That is nitrogen. Right? Nitrogen is your answer. What's nickel? Nickel is Ni. How about nobelium? Nobelium. Well, you didn't have to memorize that one. But I think nobelium is, let me see, I'm trying to find it on the periodic table. Nobelium, it's either, I think it's No. Nobelium. Yeah. Niobium, I'm pretty sure is Nb. Niobium. Yeah, Nb. That's niobium. Neon is Ne. And nitrogen is N. Okay. Now, neon, niobium and nobelium, I don't think I had you memorize those. All right, number 26. Choose the pair in which the components have the same charge. All right, so we have to look at each one actually to decide which one. We could start from top to bottom, and since we don't have any oddballs, wonky ones like 2 of the above, none of the above, all of the above, and that type of thing, then if you start from the top and you find the right answer, you can stop. So the first one is a hydrogen atom and an electron. What's a hydrogen atom? It has 1 proton and 1 electron, right? So this is essentially 1 proton. The same charge, and electron is negative, right? So A is not it. an electron and a neutron. Well, an electron is that, a neutron is that. They don't have the same charge. How about C? A neutron and a hydrogen atom. Neutron has a neutral charge. The hydrogen atom is neutral also. They're not the same physically or chemically, but they are both neutral. That was the question. They have the same charge, right? So we did find an answer. A proton and a hydrogen atom, no. Proton's positive, hydrogen's no, zero charge. And a proton and a neutron have different charges. So we found our answer. Remember, you got to know what the question is before you can find the answer. 28. The number of protons in the nucleus of an atom is called its, just memorize this one, atomic number. That's the atomic number. Which atomic particle determines the chemical behavior of an atom? Think of it in these terms. What do we mean by chemical behavior? Chemical behavior points a finger at reactivity. And reactivity is not an atom sitting by itself. Reactivity is an atom approaching another atom. How do they behave with one another? Okay, once you've identified that, what do these atoms see as they approach? The first thing that contacts these two atoms is electrons. We know that now because of Rutherford's nuclear model, which puts all the protons and neutrons in the nucleus, and the electrons are out here. So, which atomic particle determines the chemical behavior of an atom? The electron. Number 30. What's the most abundant element on the Earth, including the crust, the oceans, and the atmosphere? Okay, in this case, I still think we're talking about mass. Okay. And I believe that's what's meant by abundant. So what's the most abundant? Well, if we're talking about the crust, oceans, and atmosphere, I would say oceans and lakes also. And atmosphere. Okay. Well, the atmosphere is 21% oxygen. The crust is composed of metals mostly and non-metals, but they're largely, not all, but largely combined with oxygen. They are oxides of the metals and oxides of, say, silicon. Silicon is very common in the crust. So silicon dioxide and various complex minerals based upon silicon. And you have metals combined with oxygen. The oceans and the lakes, you're talking about water, right? So there's your oxygen, oxygen, oxygen. That is the most abundant element on the Earth, oxygen, at least in terms of mass. Let's see, 31. An atom with 15 protons and 16 neutrons is an atom of what? Well, if it's got 15 protons, right? To answer the question, that's all you need, because the number of protons is unique for each element. So you look it up in the periodic table, 15 protons. That's phosphorus. All right. Number 33. A certain isotope, X2 plus, okay? We have an isotope here with a charge. It has 37 electrons, right? 73 neutrons. Okay. What's the mass number for this element? In order to determine the mass number, we need the number of protons and the number of neutrons. We got the neutrons right here. We have 37 electrons, but this thing has a 2 plus charge, which means it has 2 protons in excess of the electrons. That's why it's a 2 plus. So that means this has to be 39. And when we add that together, 112. Okay. The answer is B. 112 is the mass number. Remember, the mass number is always a whole number because it's the summation of protons and neutrons. Whereas the atomic mass, I think we did get there. The atomic mass is a weighted average of all the individual isotopes of that element. All right, we're going to skip down to 37. How many phosphorus atoms are represented by one formula unit of cobalt-2 phosphate? Now, the creator of this question was kind enough to give you the formula. You should be able to write that compound. Cobalt-2 phosphate. Okay. Cobalt. Phosphate. There's no element by the name phosphate. That is a polyatomic ion. So you look it up in your chart, the polyatomic chart, and you find that this is a PO4 with a 3 minus charge. Cobalt has a 2 plus charge. Says so right there in the name. Now, how do you reconcile 2 plus charge here and 3 minus charge there? If we just leave it that way, there's a static charge of a -1. Okay, so the best way to accommodate and balance the charge is cross multiply. Put that 3 over here, and put that 2 over there. So that's 2 times 3 minus is 6 minus, and 3 times 2 plus is 6 plus, right? There you go. So that's how we got that formula. Now, the question is, how many phosphorus atoms are in that formula unit? Well, for this formula unit, you have 1 phosphorus in each phosphate, but you have 2 phosphates. So there are 2 phosphorus atoms in that formula unit. Number 39. How many atoms are represented by 1 formula unit of aluminum chromate? Here we go again. And they're kind enough to give you the formula. But you should be able to construct that formula from the name. Okay. First of all, is this a type 1, type 2, or type 3? Well, it's a metal and a polyatomic ion. So based upon the metal, it's either a 1 or a 2. So what's the difference? Well, the 1 has a fixed charge. Does aluminum have a fixed charge as an ion? Yes, it does. It has a 3+ charge. How about chromate? Look it up in your table. Chromate has a 2- charge. So here we go again. This time we knew what the charge was because it's fixed and we know where it's located in the periodic table. It's actually 3 columns to the right if you skip the transition metals, which makes it a 3+. So we just put a 2 over here, right? And we put a 3 over here. And remember, anytime you need more than one polyatomic, you have to use parentheses because that charge is distributed over the entire, the entire formula for that polyatomic. Okay, now what's the question? How many atoms are represented by one formula unit? So how many total atoms? Well, we have 2 aluminums, we have 3 chromiums, and we have 12 oxygens. So that's 17, right? 17 atoms in that formula unit. Number 40. Which of the following statements are true? All right, let's see. Part of mine is blocked, so I'll have to read from the screen. Well, let's see. Roman numeral 1, 2, 3, and 4. 1 says models are always wrong unless they are proved by a theory. No, that's false. We're not saying models are wrong, and we're not saying that they can be proved. Models are simply a simplified representation of what the theory is trying to explain. It's like you have a model of a battleship that you've put together. Is that the battleship? No, it's not. It's a model. It's a representation of the battleship. All right. How about 2, excuse me. Elements such as lead are made of tiny particles that mostly consist of open space. Yeah, elements such as lead. In fact, all elements are mostly space. So this one is true. 3, the air you breathe is an example of a heterogeneous mixture. Oh yeah. Nitrogen and oxygen, primarily. And then there's some argon, and there's some water vapor, and there's some CO2, and various other components, but they're all homogeneous. Oh, wait a minute. That's heterogeneous. That's false. Sorry. I misread. Air is a homogeneous mixture, not heterogeneous. Okay, number 4. Because ammonia always, that's NH3 is ammonia, always contains the same relative number of atoms, it will always contain 4.6 grams of nitrogen for every 1 gram of hydrogen. Well, yeah, the ratio is fixed. That's true. But is 4.6 to 1 gram also true? NH3. So the ratio then is if 1 atom of nitrogen or 1 mole of nitrogen actually is representative of 14.01 grams. And 3 hydrogens is 3.03. So is that correct? Well, let's get our calculator and see. Probably is, right? We could, if we estimate, right, 3 into 14 is about, let's see, 3 times 4 is 12 with 2 left over, and that's about 2/3. So 4.6, it seems reasonable. Let's see if it is. 3.03. Yeah, 4.62 actually. So yeah, this one's true. So that one's true and that one's true. Roman numeral 2 and Roman numeral 4, which is B. Okay. Let's make some room here. Um, 42. Which pair have approximately the same mass? Okay, we're looking at, let's see, elementary particles. Okay, there's an element and isotopes. So when you look at each one, actually, approximately the same mass. Didn't say exactly, approximately. Protons and neutrons, yeah. They're approximately equal in mass, right? So A is true. How about the others? Electron and proton? No. An electron is about, a proton is about 1,800 times as massive as an electron. C, a hydrogen atom and a deuterium atom. No, they won't be the same. Why? That's false. C, hydrogen atom, or it's often called a protium, is like that, and deuterium is like this. It has an extra neutron, which makes it much more massive. Okay, so that one's false. D, a neutron and electron. Well, that's a similar statement to the proton and electron. So D is also false. And E, a hydrogen atom and a tritium atom. Well, there you have this one and this one. Right. So that, excuse me, E. That one's false also. So the only correct answer in that group is A. Number 43. How many nitrogen atoms are indicated by the formula AlNO2? Let's see, AlNO2 3 times. First of all, is that correct? Well, we know aluminum is 3+. It's always the 3+. Nitrite is a -1 charge. So 3 times that minus is the 3 minus, 3+. Yep. That balances. Now the question, how many nitrogen atoms? Well, we got 3. 3 nitrogen atoms, which is E. Let's see. Just because I'm skipping these doesn't mean you shouldn't try them. You should try every problem in the review document, actually. But these are representative ones. 48. How many protons are in the atom carbon? This is where you don't have enough information in the problem, the question itself. So you got to go to your periodic table and you look up carbon and you find it has 6 protons. About 51. The symbol SN stands for what element? All right. That's one of those Latin element names, stannum. Stannum, SN, is 10. Right? That's why you can read on the side of a toothpaste tube, stannous chloride or stannous whatever. They're referencing 10, stannous fluoride, I should say. Stannous fluoride is a common delivery method for fluorine in your toothpaste. All right, 55. Okay, how many protons, electrons, neutrons are in this particular ion? Sc with a 2+ charge and 45 mass number. What is Sc? That's one of those I had you memorize. That's scandium. It's a transition metal, and you can find it in the 4th period. It has 21 protons. So in order, protons, electrons, neutrons. Protons, electrons, neutrons. Protons, 21. It has a 2+ charge, which means it's deficient in 2 electrons, which means instead of 21, we have 19. And the neutrons are 21 from 45, which is 24. 21, 19, 24, which is B. About 61. Let's do a little cleanup here. There we go. All right. 61. The average mass of boron atom is 10.81. 10.81 for boron. That could be atomic mass units, or it could be grams per mole. Either one is fine. Assuming you were able to isolate only one boron atom. Okay, so we're talking about atomic mass units. One boron atom. Okay, the chance that you would randomly get one with a mass of 10.81 is, what's the probability of finding one atom with exactly that mass? The probability is 0. This is a weighted average of a collection, naturally occurring isotopes of boron, which each isotope has a different mass than 10.81. You get that number by a weighted average of those values. None of them weigh 10.81 atomic mass units. All right. Let's check 62 while we're here. Right? It's important to know who did what. I mean, these people spent their entire lives doing this stuff, and they ought to get credit for major discoveries. The first scientist to develop a theory that all atoms of a given element are identical. All atoms of a given element are identical was John Dalton, his atomic theory. That's a statement right out of his atomic theory. John Dalton. All right, let's go down to 65. Which of the following elements is most similar to chlorine? 65. So what are we saying there? What do we mean by most similar to? We're speaking of chemistry. Which of these elements behaves most like chlorine? it's going to be one that's in the chlorine group, in the halogens. So you look, say, which ones of these are halogens? Helium? No. Mercury? No. Hydrogen? No. Sodium? Alkali metal? No. Bromine? That's another halogen. So bromine is like chlorine. Fluorine is like chlorine. Iodine is like chlorine. Astatine. They're all halogens. They behave similarly, not exactly alike. They're just similar in their behavior. All right, number 70. How many protons, electrons, neutrons are in this one? All right, that isotope of what P? Phosphorus. So we look it up, we find out how many protons there are. 15. Right? Then we want protons, electrons, neutrons. Protons, electrons, neutrons. Okay, protons easy. Is this neutral? Yep, it's neutral. The number of electrons has to be exactly the same. And then we subtract the 2 and we get 16 neutrons. So 15, 15, 16. C is the answer. Uh, 71. All right, which of the following contains the largest number of oxygen atoms? Right, so you add up the number of atoms. A, B, C, D, E. In each formula. So in the first formula, how many oxygen atoms do we have? Well, 4 times H2O is 4 oxygens. Right? Number of oxygen atoms. B is just 1 ozone, which is 3 oxygens. Then H2SO4 is one of those units, which has 4 oxygens. And D has 3 carbon dioxide. So there are 2 oxygens in each formula, but we have 3 of them. So there's 6. And the last one, we have aluminum nitrate, NO3, taken 3 times. So 3 times 3 is 9. There's your answer. That has the largest number of oxygen atoms in the representations of each of those compounds. Well, actually, ozone's not a compound. It's a molecule of oxygen. 72. How many atoms of oxygen are in one formula unit of calcium dihydrogen phosphate? Okay, this one, you got to figure it out. Calcium dihydrogen phosphate. That is a polyatomic ion. Look it up, because you're going to need to know the charge. Dihydrogen phosphate is a -1 charge. Calcium is an alkaline earth, which only has 2+ charge. All alkaline earths are 2+ charge. So that means we need 2 of these, correct? Here we go. That's your formula. How many oxygen atoms are in that formula? We have 4 here, times 2 is 8. 8 oxygen atoms. Okay. Let's see, how about 75? Which of the following statements are true? Which of the following statements is or are true? There may only be one true. Let's see. Let's look at our answers. 1, 2, and 3 are all false. Okay. B, only 1 and 2 are true. 1, 2, and 3 are true. D is 2 and 3 are true. 1 and 3 are true. Okay, so there's not one single one that we're saying is true. They could be all false. So let's look at each statement and try to determine its validity. The number of protons in an element, this is Roman numeral 1, number of protons in an element is the same for all neutral atoms of that element. That is true. The number of protons identifies the element. Roman numeral 2, the number of electrons in an element is the same for all neutral atoms of that element. The number of electrons in an element is the same for all neutral atoms of that element. Yes, because they will have exactly the same number of electrons as protons if it's neutral. So that one's true. How about 3? The number of neutrons in an element is the same for all neutral atoms of that element. Nope. Why? Isotopes. So only 1 and 2 are true. All right, that's chapter 4. And it's only 10 o'clock. And we've got another hour. So I think I'm going to continue with chapter 5 and see if I can finish chapter 5. And the reason I want to do that is rather than split it between 2, there's the logistics of processing the video. But I think it's more important that my students have access to a review earlier than later, because the exam's going to come, let's see, today's Thursday, Tuesday. It's going to come a week from today. And if I can give you a week to review chapter 5 and chapter 4, that's better than chapter 4 now and chapter 5 on Tuesday, which gives you only 2 days to work chapter 5. So I'm going to finish chapter 5 today. And Tuesday, I'll come back. I'll be zoomed in. So if any students are interested in specific problems, then I'll be here. I'll stay here for about 20 minutes, So if you want to discuss anything over Zoom, then I'll be here and we'll have the board available and I can pull up anything on the screen. But if nobody shows up after about 20 minutes, I will retire to my office. And then you'll have to contact me by alternate means if you have questions. And then the following Thursday, we should have, yes, Thursday the 13th will be exam number 2 on chapters 4 and 5. Okay, let's get on with chapter 5 now. Number 76. The correct formula for carbon monoxide. All right, first of all, if you have carbon and oxygen, what type is that in the naming convention? It's a nonmetal and a nonmetal. That's the type 3, right? We could figure that out from this and that. But we also know that if we say mono in front of one of the elements, that's a type 3. It's because we don't use that convention in types 1 and 2. So this carbon monoxide, that's it, CO. 77. Which of the following is a binary compound? Well, according to your textbook, A binary compound only has two elements. So we look at the selection here, even though we have polyatomic ions involved, and we use the binary naming convention for polyatomics. Your textbook doesn't consider them binary. So the only binary compound in there is H2S. Hydrogen and sulfur. That's a fine distinction, but it's true. 79. The correct name for an aqueous solution of HC2H3O2. HC2H3O2 aqueous. All right. When we look at that formula, what do we see first? We see a hydrogen. We see hydrogen here and we see hydrogen there. This hydrogen makes this an acid if we put it in water. So we would, if it were not that way, we would say hydrogen acetate. That is a polyatomic ion, acetate. Once we put it in water, now we have to say, is there oxygen? Yes, there is oxygen. So we don't say hydro. We actually go to this part of the molecule and change ATE to IC. So we say acetic acid. That's it. Acetic acid is it. Number 80. Na plus represents what? Na plus. Well, Na is sodium, right? Sodium. But it's not neutral sodium. It's not the neutral metal. This is an ion, sodium ion. Now, do we need to say what the charge is? No, that would be redundant. This is unambiguous, just like that, because sodium is an alkali metal, and all alkali metals make +1 ions. So sodium ion is C. All right. '81. Okay. Here's why I put this one in here. Mercury is a little bit odd about how it forms ions. Okay. Mercury can form two different ions. It's one of those metals that doesn't have a fixed charge. But when mercury forms an ion, it's either this or it binds two mercuries together and makes, so they're both 2+, but this one is 2+ for one atom of mercury, and this is 2+ for two atoms of mercury. So the charge on each one is a +1. So there you have, if you look in your periodic table and you see mercury, you'll see in the upper right-hand corner, probably, a +1 and a +2. But this is how you write them, right? This has to be, let's see, that's this one. So this is a mercury 1 ion. Okay, that's why I put that one in there, because this one is kind of strange. It's the only one that, well, there may be others that do it, but this is the only one you need to know. 82. Which is the correct name of the compound that results from the most stable ion of sulfur and a metal that contains 24 electrons? So the metal has 24 electrons. Now, we have to assume that there's only one atom of the metal. The most stable ion for sulfur, it's a chalcogen. Oxygen, sulfur, selenium, tellurium, polonium, they should be two minus charge. So this would have to be a 2 plus. That means if it's 2 plus, it has 26 protons. So we look up 26 and find that it's iron. Right? So we would write Fe S, and this would be iron 2 plus sulfide. Okay. All right. About 83. The symbol for the rubidium ion, right? We know that rubidium is this, but what ion does it make? Well, let's find it. Rubidium is an alkaline metal. +1 charge. That's it. Correct formula for barium hydroxide. Barium and hydroxide is a polyatomic ion. So it's OH minus. What's the charge on barium? Do we know? Yeah, barium is an alkaline earth. It's always 2 plus. So that means we need 2 of those without the charge for our purposes here. So E, BaOH taken twice is the correct answer. All right, 85, 85. The correct formula for lead-4 nitrate. Lead has a 4 plus charge, right? It's a type 2 compound. We know that from the name. And nitrate is a polyatomic ion with a -1 charge. So to balance the charges, we need 4. PbNO3 taken 4 times. That would be D. Okay. 86. It says the name for the acid HNO2. We're specifying this as an acid. So it would have to be an aqueous solution. There's an oxygen, so we don't say hydro. So what is this polyatomic group then? This is nitrite. Ites become us. So this is nitrous acid. Okay. 86. 87, I think. 87? Yep. The correct formula for the ammonium ion. That's one you just look up. Right? Look up in your list of polyatomics. It's the only positive polyatomic in that group. 88. The name of AlO3. AlOH3, excuse me. Right? We don't have to say what the charge is on aluminum because it's fixed. This is a type 1 compound. Aluminum, OH is what? Hydroxide. And we don't say how many hydroxides either. So aluminum hydroxide would be A, the first one. 89. The correct name for an aqueous solution of HCN. Okay, this is aqueous. We say, okay, is it an acid? Yes, it's an acid. All right, so we look at this part, and we also, since there's no oxygen, we say hydro. Well, actually, if it were not aqueous solution, it would be hydrogen cyanide. But since it's an aqueous solution, we say hydro, and IDE becomes ic, hydrocyanic acid. There you go. Hydrocyanic acid, which is D. Okay. Next, 91. Which of the following is named correctly? Okay, so we've got unique ones for each one. We have to figure out which one is named correctly. Okay, the first one, HCl aqueous. HCl aqueous. That should be hydrochloric acid. Is that it? Nope. That one's wrong. B, HNO3 aqueous. HNO3 aqueous. Okay, we've got an oxygen, so we don't say hydro. We look at this part. The nitrate ions, 8s become X. So it's nitric acid. Is that right? Yeah, that's right. That one's true. And since we don't have any wonky ones in there, C, NH3 is ammonia. NH3 is ammonia, not ammonium. NH4, PO4, like that. Yep. This is not ammonium phosphate. Oops, that's my mistake. This is ammonium phosphite. PO3 is phosphite. And H2SO3, aqueous, is, this is sulfite, so it's sulfurous acid. Right. So these are wrong as given. These are correct names. But this is the only one that's correct in the problem. 92. Let's make some room here. The substance, ClO3 minus. Okay. Is best described as, well, let's see what our choices are. Polyatomic molecule, polyatomic ion, molecule, mixture, compound. It's an ion. It's not a compound. It's pure substance. It's not a mixture. It's not a molecule because it's not neutral. Polyatomic ion is best name for that one. Let's keep it going. Stop on 97. Sodium chlorite has the formula. All right, sodium chlorite. All right. So we know it's going to have this. How about chlorite? What is chlorite? If you look it up in your, in your polyatomic list, chlorite is ClO2 minus. ClO2 minus. Charge is balanced. So that's all we have to write. NaClO2. That's sodium chlorite. The next one below it is sodium hypochlorite. And everybody knows that. Well, maybe they don't, but everybody uses that. That's bleach. 5 or 6% of that in aqueous solution is bleach. 98. Down here. Do 98. The correct name for an aqueous solution of H2SO4. H2SO4, aqueous, right? Has oxygen in it, so don't say hydro. Has a hydrogen here, 1 or 2 hydrogens. This is an acid. So we go back to this one, sulfate, 8 becomes ic. Sulfuric acid. Go. Sulfuric acid, very popular in the steel working industry. They use it to pickle steel, clean up the steel. Or they use it in paper manufacturing. It breaks down the cellulose from the lignin and separate, so you can separate the two. That's why when you drive by either a steel plant or a paper plant, you smell sulfur dioxide. It smells horrible. Well, actually, if you work there, it smells like money. All right, 101. Okay. The formula for the compound formed from the polyatomic ions NH4 and PO4 minus. NH4 and PO4 minus. We just need 3 positives to balance that one. Yeah. NH4 taken 3 times PO4. A is your answer. Correct name for HCl, aqueous solution. Is that 103? Yeah. So if we put this in an aqueous solution, we don't say hydro, we look for this. I becomes ic. We say hydro, excuse me. We don't have an oxygen, so we do say hydro. Hydrochloric acid. Go. 105, compound PI3. Says 105. We want to name PI3. All right, type 1, type 2, type 3. These are both non-metals, type 3. So we say phosphorus, triiodide. Right. And we don't say monophosphorus because it's the first one. It assumes the cation position. So phosphorus triiodide, A is your correct answer. How about 107? The name of Pb4 plus. Pb4 plus. This is lead. It's a lead ion. But do we have to say what the charge is? Yes, because lead is type 2. In other words, it has multiple possible charges. So we have to say what the charge is. So we say lead lead 4 ion. Selenium trioxide. Is that correctly? Do we need to say trioxide? I mean, is this a type 3 compound? Oh, look, say selenium. Yeah, selenium is a nonmetal and it has 3 oxygens. So we would say selenium trioxide. And more examples there. We skipped over those. Which of the following compounds is not named as an acid? Right. So let's go 115. Let's see, are they all aqueous? Yes. Okay. Do they all start with hydrogen? No. So we can save ourselves a lot of time. NH3 aqueous is not an acid. In fact, it's a base, but we don't have time to go into that right now. We haven't covered that yet. How about 117? What is the formula for gold 1 oxide? Should we say gold 1? Yeah. Gold's a transition metal. It can have more than one charge. So gold 1 oxide is Au, right? And then oxygen is 2 minus, so we need 2 of these. So Au2O. C is your answer. G is not an element. There are no elements in the periodic table with only G. And there's a reason for that. You have some, let's see, Ga is gallium, Ge is germanium, but none are G. And that's probably because G is reserved for a variable in some other formula. And we don't want to get it confused with elements. So we don't use pure G for anything. The answer to this one is C, Au2O. Number 121. Okay. The carbonate ion has the formula CO3 2 minus. That's correct. Okay. What is the correct formula for sodium carbonate? What's the charge on sodium? It's an alkaline metal, so it has like that. That means that we need 2 of those to balance the charge. Na2CO3. That's E. All right. Let's clear the board. $124. Okay. Which of the following represents the hypochlorite ion? If you don't have it memorized, you can look at the table and find that the hypochlorite ion is ClO minus. 125. What is the formula for calcium hydroxide? All right, we know we got calcium. We know we got hydroxide, which is a -1 charge. What's the charge on calcium? It's an alkaline earth, which means it's fixed. And the name should give you a clue. We don't say what the charge on calcium is, so it must be fixed. It's a 2+. So that means we need 2 of those. CaOH taken 2 times. E is your answer. 127. the name for HBRO, aqueous. HBRO. Okay, hydrogen, aqueous, this is an acid. So we have to go here. We don't say hydro. What is BRO? BRO is the hypobromite ion. So ITE is us. Oops, let's fix that. And hypobromous acid. Okay, 128. H2SO3. And we're told it's an acid, right? So it has to be an aqueous solution. There's an oxygen there, so we look at this one first. We don't say hydro. SO3 is sulfite. And ites become us's. So it's sulfurous acid. Okay. P2O5, that's 129. I think we did this one in class. Yeah, we did that one for a lecture. What type of compound is this? It's two nonmetals. It's a type 3. So we have to say diphosphorus penta or pentoxide. We drop the A just because it sounds better. So that would be E. Correct answer for that one. Okay. Oops, did I skip one? No, I didn't. Okay. 132. Correct formula for silver iodide. 132. Is that the correct name? Silver iodide? Right. Silver is a transition metal. Shouldn't we put a Roman numeral in there? No. Silver is one of those 3 transition elements that is a fixed charge. It's a +1 charge. That's it. Just 1 silver, 1 iodine. A is your answer. Lots of other practice you can do in there. Recommended. The correct formula for lead 2 sulfite. Lead 2+ sulfite. Oops, that's sulfate. Sulfite 2-. So it's just PbSO3. That's all it's needed. E is your answer. 142. The correct formula for the carbonate ion. And you can just look that one up. Carbonate, CO3, 2-. Okay. 143. All right, this is a detective story here. A compound contains an unknown ion, X, and has the formula XCl2. Okay. Unknown ion. So we know this is either a type 1 or a 2. X is a metal. Ion X contains 20 electrons. 20 electrons. What's the charge on X? Well, this is a -1. So this means it has to be 2+. That means we have 22 protons, right? 22 protons. That's titanium. Titanium with a 2+ charge. Okay, that's A. 147, let's clear the board. Yep, 147. The name of NaHCO3. NaHCO3. This is a polyatomic ion. This is hydrogen carbonate. This is sodium. This is a +1, that's -1. Now, sodium bicarbonate is still used a lot, so we still have to accept it. This could be sodium hydrogen carbonate or sodium bicarbonate. Bicarbonate of soda is baking soda, right? That's what we call it, baking soda. Every kitchen's got some on its shelf. We use it for baking. You can also cut the top off the box, Arm & Hammer box, and stick it in your refrigerator, and it helps absorb odors. Okay, 148. I think that one's getting weak. (148). The correct name for an aqueous solution of H2CO3. H2CO3, aqueous. Acid, oxygen. So we look at what this is right here. That's carbonate. Eight becomes ic, and we don't say hydro, so it's carbonic acid. Right? If you like to drink your pop, you're drinking lots of that stuff with every guzzle. All right, 153. Make room. (153). The name for NH4Br. All right, this is ammonium, and polyatomic ions in the name of a compound do not change. They are fixed. Ammonium bromide. That's all there is to it. You don't have to say what the charge is on ammonium because it's fixed, as if it were a type 1 compound. 155. The formula for the compound formed from ammonium and sulfate. Right? Ammonium is this. Sulfate is that. So we balance the charges. We need 2 of these. That would be D. Oh, and we're done. Okay, so there's useful information. Let's see, what else? Polyatomic ions. Like I said before, the review document has useful information on the last pages. Any of those last pages on the review document will be available for the exam. If you come in face-to-face, those pages will be stapled to the exam so that you can pull them off the back. If you take the exam in Brightspace, you go into the module for that exam, and before you click on the exam and go into lockdown browser, be sure you have a copy of the document that's in there with the exam link. Right? That will be useful information that you are allowed to keep with you during the exam. Let's see what else we have. There's a periodic table, right? That's good. Okay, that's it. All right, so we're done with our review.